You know that teeth gritting moment? You tap a link, maybe your phone's got like 1 bar of signal, and nothing happens.
Yeah.
Just that little loading spinner mocking you. Feels like forever.
It really does, especially when you need that info now. So
Right.
frustrating. Breaks the whole flow.
Exactly. Well, today we're doing a deep dive into something designed to basically kill that feeling. Service workers.
Ah, yes.
Think of them like a secret weapon for web apps, making them seriously fast, maybe even work when you're totally offline.
That's a great analogy, actually. They give developers a whole new layer of control, really, over how the app talks to the network, talks to the browser.
Right.
We've gone through quite a bit of material on this technical docs, real-world impact stories, the whole lot.
And our mission today, for you listening, is to really get how they pull off this speed and reliability boost.
Mm-hmm.
We'll unpack how they take charge of that browser to internet chat. Mastering this thing called caching. We'll look at what they are, how they grab the data flying around, the different tricks for storing stuff.
Different strategies.
And, most importantly, how that makes websites load like lightning for you. We'll even peek at, the tricky bits of setting them up. Ready?
Let's do it. So the core idea, what is it about service workers? What makes them tick?
Okay, so imagine like a super efficient assistant. Stands between the website you're looking at and the big wide internet.
Okay.
That's kind of the job of a service worker. Technically, it's just a small bit of JavaScript code. Runs quietly in the background.
Right. Separate from the main browser thread.
Exactly. Totally separate from the page you see and click on.
Yeah.
And that's key, right? Because it means it could do its thing without slowing you down.
Absolutely. That background execution is crucial. It's non-blocking, asynchronous, meaning the service worker can be off doing its job, fetching data, checking storage.
While the main page stays responsive.
Precisely. It's like a dedicated helper doing chores without getting in your way.
And they have some interesting limits, too. Like, they can't just directly change what's on the screen.
The direct DOM access, yeah.
Right, the DOM. If they need to update the page, they have to, send messages back and forth.
Using things like the post message API or channel messaging.
Also, they're event-driven. They only wake up and do something when a specific thing happens.
Exactly. Events like install, activate, and the really big one, fetch, which we'll definitely get into. Those are the triggers.
Okay.
And super important for security. They only work over HTTPS, secure connections.
Makes sense. Don't want random scripts messing with your network traffic.
Right. Your own computer, when developing, localhost, that usually counts as secure too, which is handy for testing.
But the real superpower, you said, is taking control of network requests.
That's the game changer.
Yeah.
It sits there acting as this programmable middleman, this proxy.
Oh.
It gets to decide, does this request go to the internet? Do I grab something I already stored? Or maybe I just make up a response right here. And that intermediary role, that's what lets you build these incredibly resilient apps that work offline. It's really the foundation for progressive web apps, PWAs.
PWAs, right. Giving websites those app-like powers.
Exactly. The key insight is this fine-grained control developers get over network interaction and caching. It's way beyond just hoping the standard browser cache does its job.
Okay, so intercepting network requests. That sounds vital. How does that actually work? What's the mechanism?
It all revolves around an event called the fetch event.
Fetch. Okay.
So whenever a web page that's being managed or controlled by an active service worker tries to get anything from the network.
Like images, code, data.
Anything. The initial HTML, CSS, JavaScript, images, fonts, API calls. The browser fires off this fetch event inside that service worker.
So the service worker gets pinged, like, hey, page wants this URL.
Exactly that.
Yeah.
And inside the service worker's code, you write a listener for that specific event. When it fires, you get an object, a fetch event object.
When that tells it what the page wants.
All the details. The most crucial part is event.request. That tells you the URL, the method like GET or PT or PUST, the headers, everything about the outgoing request.
Got it. So it knows exactly what's being asked for.
Precisely. And then comes the magic part. The event.respondWith method.
Respond with.
This is the service worker basically saying, hold on, browser, I got this. You call that method and you give it a promise.
A promise. Like, I promise I'll get you an answer.
Sort of, yeah. It's a placeholder for the eventual result. The service worker promises to provide a response object, and it can fulfill that promise by getting it from its cache or going to the network itself or even generating it.
Okay, so it intercepts, then it promises a response using respond with.
That's the core loop. That's what gives it control.
And What if it doesn't call respond with? If it just ignores the fetch event?
Good question. If respond with isn't called for a particular request, the service worker just steps aside. The request goes straight to the network like normal, as if the service worker wasn't even there.
Ah, okay. So developers can choose which requests to handle.
Exactly. They can filter, say, only handle image requests, or let API calls go through, whatever logic they need.
So intercepting with fetch, deciding with code, and answering with respond with, that turns it into this programmable network gatekeeper.
Perfect description. A programmable proxy deciding where the data comes from, network, cache, or maybe something generated on the fly.
And that's the foundation for all those caching strategies you mentioned.
Exactly. That's where the real performance gains start kicking in for the user.
Okay, let's dive into those strategies then. I know there are a few main ones. Where should we start? Cache first.
Yeah, let's start with cache first, sometimes called cache falling back to network.
Yep.
It's pretty straightforward.
Yep.
Service worker intercepts the request. First thing it does, checks its own storage, its cache. Do I have this already?
Yes, it does.
If yes, bang! It serves that cached version immediately, no network needed, super fast.
Instant load for things it has. Nice.
Right. Now, if it doesn't find it in the cache,
Then it goes to the network.
then it goes to the network like normal, fetches the resource, gets the response, and then usually it saves a copy of that response in its cache before sending it back to the page.
So it stocks up for next time.
Exactly. So the next time that same thing is requested, it'll be in the cache, ready for that instant hit.
What's this best for? Like website logos,
Yeah.
core
The
styles.
perfect examples, static assets, things that don't change often. The app shell, CSS, JavaScript bundles, fonts, maybe unchanging background images, often used with pre-caching too,
Pre-caching.
where the service worker downloads and saves these key things right when it's first installed, so they're guaranteed to be there from the start.
Okay, cache first sounds great for speed, but what if the thing is changed on the server, but I still have the old version in my cache?
That's the trade-off. You prioritize speed, but you risk serving stale data. Getting the absolute latest version usually requires the service worker itself to be updated, which then refreshes the pre-cached assets or triggers other cache clearing logic.
Right, okay, so what's the opposite approach? Always checking the network first.
That would be network first, or network falling back to cache.
Makes sense.
Here, the service worker intercepts the request and immediately tries to fetch it from the network, tries to get the freshest version possible.
Okay.
If that network request succeeds, great. It sends the response to the page, and often it'll update its cache with this fresh copy.
So it keeps the cache up to date that way.
Yep. But what if the network fails? Maybe you just went into a tunnel, lost signal.
Oh.
Then the service worker checks its cache. If it finds a previously saved version of that resource,
It serves that instead, like a backup.
exactly. It serves the cached version as a fallback. So you might not get the absolute latest, but you still get something, even if you're off long at that moment.
Okay, that sounds much better for things that change frequently, like news headlines or maybe my user profile data.
Precisely. Things where freshness is important, API responses, dynamic content. The downside is, if you are online, you always have that slight network delay, even if a perfectly good version was sitting in the cache.
Right. You wait for the network check first.
But for offline users, getting that cached fallback is way better than just seeing an error page.
Definitely. Now, what about that middle ground? The one where you get something fast, but it checks for updates behind the scenes.
Stale-While-Revalidate. That's a really popular and clever one.
How does that work?
Okay, request comes in, service worker immediately checks the cache. If it finds it, serves it straight away, feels instant.
Nice. Speed first.
But at the same time, or right after, it also kicks off a request to the network for that same resource in the background.
See.
If that network request succeeds and gets a newer version,
It updates the
it
cache.
updates the cache silently. So the next time you request it, you'll get the fresh version instantly from the cache.
So I get fast access now, and it fixes itself for later. That sounds really practical.
It's a great balance for many things. User avatars, maybe social media feeds that aren't mission critical, background images. Things where seeing slightly stale data for a moment is okay if it means the initial load is super fast.
The trade-off being you might see old stuff for a split second.
Exactly. Until that background update completes. But often that's a very acceptable compromise.
Okay. Are there times you'd only want the cache? Like, never even try the network.
Yep. Cache only. Dead simple.
Just look in the cache.
Just look in the cache. If it's there, serve it. If it's not there,
Fail.
request fails. No network attempt is made.
Huh. That sounds limited. When would that be useful?
Primarily for things you are absolutely certain were pre-cached during the service worker install. Essential offline assets, maybe a custom UR offline page itself, is served this way.
Ah, like the absolute bare minimum to make the app function offline.
Right. The key is these things only get updated when the service worker itself is updated and the pre-cache list changes.
Got it. And the flip side, never use the cache, always network.
Network only. Again, pretty self-explanatory.
Service worker just ignores the cache completely.
Ignores the cache, sends the request straight to the network every time. This is actually the default if you intercept a fetch event but don't call respond with.
When would you deliberately force network only?
Things you absolutely never want cached. Sensitive data is a big one.
Yeah.
Or requests that aren't just fetching data, like submitting a form, a POST request usually, making a payment. Analytics pings often fall into this category too.
Makes sense. You don't want to accidentally cache sending your password or something.
Exactly. Of course, the downside is you lose all caching benefits for those specific requests. No speed boost, no offline fallback.
It really sounds like a good web app would mix and match these, wouldn't it? Use different strategies for different types of content.
Absolutely. That's the smart way to do it. Use cache first for the app shell and fonts, maybe Stale-While-Revalidate for avatars, network first for important API data, network only for form submissions.
Tailoring the strategy to the resource.
Precisely. And like we mentioned, libraries like Workbox really help here. They provide ready-made functions for these strategies, so developers don't have to reinvent the wheel every time. Takes away a lot of the boilerplate code.
Okay, so this service worker caching sounds way more powerful than, the regular browser cache thing.
Way.
What are the big differences for me just wanting faster websites?
That's a great question to clarify. They both try to speed things up by storing stuff locally, but they operate very differently. Think about control.
Okay.
Traditional HTTP caching this stuff controlled by cache control headers from the server. It's mostly the server telling the browser what to do. Keep this for an hour, check back with me before using this again.
Right, the server's in charge.
Largely, yes. Service worker caching. The control is right there in the website's JavaScript running in your browser. The developer writes code to decide exactly how caching works. Much more granular control.
So the website developer has more direct say.
Way more. Which leads directly to the next big difference. Offline capability.
Ah, yes, the holy grail.
HTTP cache is unreliable offline. If something happens to be cached and not expired, maybe it works. No guarantees. Service workers are designed for offline. Strategies like cache first or cache only ensure things are available. Custom offline pages are easy.
That's a massive advantage. No more dinosaur game unless I choose to play it.
Exactly. Then there's persistence. How long stuff sticks around.
Okay.
HTTP cache is managed by the browser. It might kick things out if space gets low, or based on its own internal logic, it's unpredictable.
Right, cache clearing happens.
Service worker caches use a dedicated origin-specific storage space. It's generally more persistent. Developers have explicit control over adding and removing things. It's less likely that crucial offline assets will just vanish.
So more reliable storage, too.
Generally, yes. And flexibility is the other big one. HTTP caching is limited by those standard header directives.
Time limits, validation tags.
Right. Service workers, the logic can be incredibly flexible. Cache based on network speed. Cache different things for logged-in users. Modify requests before caching. Modify responses. All possible.
Wow, okay. So they're not really replacing the HTTP cache, are they? More like adding a smarter layer on top.
That's a good way to think about it. They work together, but separately. The service worker intercepts the request first.
Before the HTTP cache even sees it.
Usually, yes. If the service worker decides, okay, I need to actually fetch this from the network, that network request it makes might then interact with the HTTP cache.
Ah, okay. So the HTTP cache could still cache the response that the service worker fetched.
It could, which can sometimes cause headaches for developers if the HTTP cache serves an old version when the service worker expected a fresh one from the network. They sometimes need to add specific instructions to bypass the HTTP cache within the service worker fetch handler.
Tricky interactions there. But overall, the service worker gives much more power for performance and offline.
Definitely. It's a more robust, programmable layer specifically designed for those modern web app needs.
Okay, so we understand the how. What's the actual impact? How much faster does this make things for me, especially when I'm on, dodgy conference Wi-Fi or out in the sticks with one bar?
This is where you really feel the difference. The impact on load times can be dramatic, especially on those poor network conditions.
Tell me more. Faster is better.
So, by serving stuff from the local cache, you skip the entire network round trip, right? Sending the request out, waiting, getting the response back, gone,
Just grabs it from the device.
which massively reduces latency. Even on a fast connection, eliminating those network hops for cached assets makes things feel noticeably snappier, more instant.
Okay, so faster even on good connections.
But the difference is huge on slow networks. 2G, 3G, fetching anything can take ages.
Painfully slow.
Service workers just bypass that bottleneck entirely for cached resources. Cache first, Stale-While-Revalidate. They make sure you see something quickly, instead of staring at a blank screen. It can make an app feel usable when it otherwise wouldn't be.
That sounds like a lifesaver.
And then, of course, the ultimate speed boost. Offline access. If the necessary stuff is cached, the load time is effectively zero network time. It just works.
Which is impossible with just HTTP caching, really.
Not reliably, no. Plus, you save bandwidth, which is great if you're on a limited data plan.
True. Less data used.
And it boosts reliability. If the network flakes out mid-load, or the server has a hiccup, the service worker can often serve a cached version or a fallback page instead of just showing an ugly error, makes the whole experience less fragile.
It sounds almost too good to be true. Is there any performance cost? Does the service worker itself slow things down?
There's a tiny, tiny overhead. The browser has to start the service worker process, run the JavaScript code for the fetch event.
But negligible compared to network delays.
Almost always, yes. Especially for repeat visits where the service worker is likely already running or starts quickly. And particularly on slow networks, the caching gains dwarf that small overhead. Studies consistently show improvements in perceived load time, like time to first paint. And developers can even get clever, like detecting a slow connection and having the service worker intentionally request smaller images to speed things up further.
So the benefits, especially in those frustrating slow network situations, are pretty clear.
Absolutely. It directly tackles that initial pain point you described.
And how does this faster, more reliable experience translate into usability? You used that great word, fruibility, earlier. Does it just feel better to use?
Ah, yes, fruibility. It's all about making the app feel smooth, fluid, enjoyable.
Yeah.
And yes, these performance gains directly feed into that in several really noticeable ways.
Like what?
Well, first, that instant loading for returning users. When the core parts of the app pop up immediately from the cache.
No waiting.
Exactly. It dramatically improves your perception of the app. It feels responsive, high quality. You're not left wondering if it's broken.
Yeah, that wait time really kills the mood.
Then there's the seamless offline experience. Being able to open an app on the subway or in an area with no signal and still access previously viewed articles or browse a cached product catalog.
Or even type a message that sends later.
Potentially, yeah, using background sync. That eliminates huge points of frustration. It makes the app feel dependable, always there for you.
That train journey example is hitting home right now.
Definitely. And the reliability aspect, too. Apps that don't crash or show error screens just because the network blipped for a second. They just feel more solid, more trustworthy.
Less likely to just give up and close it.
Exactly. And all this faster loading, smoother interaction, reliability, and it makes the web app feel less like a website and more like a native app you installed.
More happy.
Right, which encourages people to use it more. And beyond caching, service workers enable those other app-like features we touched on, push notifications, background sync, further enhancing that utility.
So it's not just speed, it's about fundamentally improving the interaction quality, making it less frustrating, more useful.
Precisely. It tackles the core annoyances of the web latency and unreliability, leading to a significantly better user experience. Fruibility.
Okay, this sounds amazing for users. But for the developers building this, how does it actually get set up? Is it super complex? You mentioned a life cycle.
Understanding the life cycle is definitely key for developers. It's different from a regular web page. It runs independently.
Right, in the background.
The first step is registration. From the website's main JavaScript, they call navigator.serviceworker.register.
Just point it to the service worker file.
Basically, yeah. Tell the browser, here's my service worker script, please run it. Good practice is to check if the browser even supports service workers first.
Feature detection, right?
And you can optionally define a scope, which parts of the website this worker should control. Defaults to the scripts directory, usually.
Okay, so register tells the browser about the script and its territory.
Yeah.
Then what?
Then the browser downloads and parses the script. If it's new or changed since the last visit, it tries to install it. This triggers the install event inside the worker.
The install event, what happens there?
This is prime time for setup, mostly pre-caching, using that cache API we talked about.
Cache.idle.
Exactly. Caches.open, then cache.idle, with the list of essential files, the app shell, core, CSS, JS, get them stored right away.
So it's ready for cache first later.
Precisely.
Hmm.
And crucially, developers wrap this work in event.wait until promise. This tells the browser, don't consider installation successful until all these downloads finish.
Prevents a half-installed worker.
Right. If any file fails to download, the whole installation fails. The worker won't proceed, ensures a clean setup.
Okay, install successful. What's next? Is it active now?
Not necessarily. After install comes the waiting state.
Waiting. Why wait?
It waits if there's already an older version of the service worker controlling open pages of that site.
To avoid conflicts between versions.
Exactly. The browser ensures only one version is active at a time for a given scope. The new one waits patiently until all pages using the old worker are closed or navigated away.
That sounds slow. What if the developer wants the update applied faster?
There's a function for that. Self.skipWaiting.
Hmm.
Called inside the install event handler of the new worker.
Tells it just jump the queue.
Pretty much, go straight to activating. But use with caution. It can lead to weird states if the new worker's caching rules are very different and it suddenly takes over pages loaded under the old rules.
Okay, tricky. So it either waits or skips waiting.
Ugh.
Then it activates.
Then it activates. Once the old worker is gone, or skip waiting was used, the new worker becomes active, triggering the activate event.
Another event. What's the job here?
Primarily cache management, cleaning up.
Getting rid of old stuff.
Exactly. Deleting old caches that belong to previous versions of the worker. Keep things tidy. Again, use event.waitUntil to ensure cleanup finishes before the worker starts handling fetches.
Makes sense. Clean house before starting work.
And there's another useful function often used here, clients.claim.
Clients.claim.
So even when a new worker activates, it doesn't automatically control pages that were already open before activation. They're still talking to the ether or maybe the old worker if it wasn't fully gone. Calling clients.claim inside the activate event tells the new worker, immediately take control of all currently open pages within your scope.
Grabs everything right away.
Yeah.
Often used with skip waiting.
Very often, yeah. To try and get the update applied consistently across all tabs as quickly as possible.
Install, set up or cache. Wait, avoid conflict. Activate. Cleanup claim. Got it. What then? Does it just run forever?
No, once it's active, it mostly becomes idle. It only spins up when an event needs handling like a fetch or a push notification.
Saves battery and resources.
Exactly. Browsers are quite aggressive about terminating idle service workers. If it's inactive for, say, 30 seconds, poof, it might get shut down.
Whoa, what happens to stuff it was doing? Or data in memory?
Any in-memory state is lost. That's why persistent state has to go into the cache API or index.dd. But don't worry, the browser automatically restarts it the very next time an event comes in for it.
Okay, so it's event-driven and potentially short-lived between events. How do updates happen automatically?
The browser handles update checks. It usually checks when you navigate to a page in the worker scope, and browsers typically check at least every 24 hours regardless.
How does it know if there's an update?
It refetches the service worker script file from the server and does a byte-for-byte comparison with the currently installed one.
Even a single character change triggers it.
Yep, even adding a comment. If it's different, the whole install, waiting, activate cycle kicks off again for the new version. That's why keeping the file name the same is crucial.
So the lifecycle handles safe updates, but developers need to manage those transitions carefully.
Exactly. It's robust, but requires careful planning.
Okay, it definitely sounds like there are complexities. What are the biggest headaches developers run into trying to actually use these things effectively?
You hit the nail on the head. While the benefits are huge, it's not trivial. The absolute #1 challenge is cache invalidation and management.
Figuring out when to throw stuff out of the cache and get new stuff?
Precisely. Unlike HTTP caching, where the server often gives hints, like expiry times, with service workers, the developer is fully responsible for managing the cache contents.
Sounds easy to mess up. Serve old content forever or delete things too soon.
Both can happen. There are various strategies. Updating the service worker script itself is one. The new worker's activate event is the prime place to delete caches associated with the old worker version.
Right. Cleanup during activation.
Versioning cache names is common too, like static v1, static v2. When v2 activates, it knows it can safely delete static v1.
Okay, makes sense.
For dynamic stuff, runtime strategies like network first or Stale-While-Revalidate handle updates more naturally as part of their flow.
They fetch new stuff anyway.
Right. Some developers get really granular, storing timestamps with cached items and using logic to decide when they're too old, maybe using IndexedDB for that metadata. And you can always explicitly cache.delete if the app knows something specific is invalid.
Lots of options, but needs thought.
Absolutely. Careful planning and testing are critical to avoid users getting stuck with stale data or a broken state. It's the hardest part to get right consistently.
Okay, cache management is tricky. What about just figuring out what's going wrong when it breaks?
Yeah.
Debugging background stuff sounds hard.
It definitely has its quirks. It's running separately, has that whole life cycle. But browser dev tools have gotten really good here.
Oh, yeah. What tools are there?
In Chrome or Firefox DevTools, there's an application tab. Under there, a service workers section. It lists registered workers, shows their status, installing, waiting, active, lets you see console logs from the worker, manually update, unregister. Very useful.
See the logs from the background script, that's key.
Totally. There are also deeper diagnostic pages like chrome.serviceworker-internals.
Right.
And during development, there are crucial checkboxes in DevTools. Update on reload forces an update check and activation on every page refresh, saves tons of time waiting for the normal cycle. Also, bypass for network temporarily disables the fetch interception so you can compare behavior with and without the worker.
Ah, A/B testing on the fly.
Kinda, yeah. Simulating offline or slow networks in DevTools is also essential for testing those strategies. And console.log is still your friend, just make sure you're looking at the worker's console, not the pages.
Can you set breakpoints? Step through the code.
Yep. In the sources panel, you can find your serviceworker.js file and set breakpoints just like regular JavaScript. You can also inspect the cache storage directly in the application tab, see exactly what's cached.
And if it all goes wrong, nuke it.
Pretty much. The clear storage options in DevTools usually include clearing service workers and their caches. Sometimes deploying a no-op worker, an empty one, can help force an old buggy one to unregister.
Sounds like the tools are there, but you need to know how to use them.
Definitely a learning curve, which is why libraries are so helpful.
Like Workbox.
Exactly. Google's Workbox abstracts away a lot of this complexity. Pre-caching, routing requests to different strategies, cache expiration rules, better debugging. It handles so much boilerplate.
Takes care of the tricky lifecycle and caching logic.
Largely, yes. Reduces errors, enforces best practices, highly recommended for anything beyond a very simple worker.
Good tip. And you mentioned they do more than just caching.
Right. While performance offline is the main focus today, they also enable push notifications.
Ah, getting messages from websites.
Background sync for deferring actions until connection returns, periodic background sync for fetching data proactively, even things like payment handlers. They unlock a lot of advanced capabilities.
Wow. Really bridging the gap between web and native apps.
That's the goal.
Yeah.
But yeah, for the user, that core promise is speed, reliability, and that smoother experience.
Okay, so wrapping this all up, the big takeaway seems to be service workers are this powerful background technology.
Right.
Developers use them to seriously speed up websites and make them reliable, which means a way better experience for us. Faster loads, offline access, less frustration.
That's the essence of it. It translates directly to user benefit. And while, yeah, implementing them involves complexity, especially around caching and lifecycle,
The payoff is huge.
the payoff in speed, reliability, and that overall fruibility is substantial. It directly tackles those common web pain points.
So for anyone listening who just hates waiting for pages to load, especially on bad connections, it's good to know this tech exists and is making things better behind the scenes.
Definitely. It's becoming more and more common because the benefits are so clear.
Right. And maybe a final thought to leave folks with.
Yeah.
Think about how many times today or yesterday you were just stuck staring at that loading spinner.
Too many probably.
Now imagine if most of those times the page just popped up instantly, or at least showed you something useful, even offline, thanks to things like service workers. How much friction would that remove from your day?
Oh, yeah.
What else could you get done?